All right, here we go. We're going to look at concept 3, absolute value. So make sure that you're putting this in your concept 3 notes so that you can use it on. So what we are going to look at first is solving absolute value equations. So we've got kind of a crazy one looking here. So this one here looks a little bit nuts. But what I want us to look at is the blue function of the absolute value is sitting right here. A couple things I want you to notice. Notice it is a -2. It's going down. If you will also notice the slope of this, we've got this nice little down 2/1 action going this way here. So it's got this nice little negative slope. And then we also have the red function is this line right here. So what we're looking for is when is it that these two guys are equal to each other. And if you notice, it happens right here and also right here. Those are the two locations. So those two locations are graphically when x is equal to 2 right here and when x is equal to 4 right here. So we're going to go ahead and solve it algebraically and see if that's indeed what it is that we get. So the first thing that we need to do is take care of this little dude right here. So we're going to move him over. We end up getting a -2. Whoops, just kidding. Equals a -2. There we go. And then we will now divide both sides by a -2. I'm getting a little excited with my negatives there. There we go. And so then we have x minus 3 is equal to a +1. So just looking at what we have here, if I plug a 4 into here, sure enough, 4 minus 3 is 1. If I plug a 2 into here, I get 2 minus 3 is -1, but remember, it ends up making it a positive. So algebraically, what we're supposed to do is split this up and say, all right, this stuff inside can either equal a 1 or it could equal a -1, either one, because you're going to make it a positive anyhow. So my answer is x is equal to 4, and x is equal to 2, and that is exactly what we got in the graphical approach in that spot, All right, so we're going to go ahead and now look at the graphing the absolute value of inequalities. So here, we're looking at exactly the same functions as we looked at in the last slide. We still have y equals 2, and we still have this function that's going down like here. So what this is saying is when is this function, the blue part, less than the red part right here. So hopefully you recognize that this is less than, and this is also less than here. So the two places that it should be equal to is pretty much any x that you plug in that way or any x that you plug in this way. So it should be that as long as the x's are less than 2 or that the x's are greater than 4, it should be true. So let's go ahead and check it out and see if we can accomplish that. So we'll move the same thing. We'll move the 4 over first. Now, here is where we have a little trickiness going on. So hopefully you remember that any time when you're dealing with inequalities, if you divide both sides by a negative, the rule states that you are supposed to flip this sign. So when we're switching this sign here, we're also going to switch that sign. Now, that's what the rule is. Let's see if that gives us our answer that we're looking for here. So let's check it out. We have x minus 3 is greater than 1. And we also have x minus 3, and we are supposed to have a -1. Now I've just switched that sign, so I need to make that a negative. So let's talk about that again. When I'm splitting this up into my two parts, I want to have a positive, this guy right here, and I want a negative. But I need to be careful. I'm going to keep the sign the same on that one, but on this one here, I'm actually going to flip it. Let's see what happens. I end up getting x is greater than 4. Yay, that's what we wanted there. And I end up getting x is less than 2. So yes, this is a rule we need to look at. Let's go ahead and look at another one and see if we can do the same thing. All right, here we go. We're going to go ahead and look at this guy here. So what I said is the rule was you go ahead and just deal with it, you know, nice little guy there. And just like all absolute values, you also have to have a negative. And since we switched this sign here, we need to switch that sign there. So that's very, very important. You want to make sure that you highlight that, indicate what's happening here. So you got to switch the signs. So we're going to have this guy and this guy. So let's go ahead and check it out. I end up getting negative x is less than negative 6 when I move over my negative 10. And now watch this. X, I now need to switch the sign because I am dividing by a negative. All right, let's go ahead and look at this one down here. So I'm going to this time again move the negative 10 over. So I have negative x is greater than negative 14. And watch this. Divide both sides by negative. Switch the sign. So those are our two. I would graph that of here is my 6, here's my 14. I want things that are greater than that and less than that. So this would be the region that I'm looking for. All right, so let's go ahead and look at a crazy one here with all sorts of things going on to make sure that we've got this down. I'm going to make this a little bit smaller. Ooh, I didn't know that those would be changing. That was cool. All right, so the first thing that I want to do is to move my negative 3. So I get negative 9. Now I'm going to divide both sides by negative. What happens when you divide both sides by negative? Did you answer? I switch the sign. Okay, so now we split this up. It's an absolute value because I want to have all that stuff inside being equal to the 1, but at the same time also to the negative. Now remember, we switched the sign here, so that means I also need to flip the switch right there. So I end up getting here x is less than 3, and here x is greater than 1. So when I graph that, I have greater than 1 and less than 3. All right. So the last couple days we've been working on absolute value, and we're going to go ahead and check it out and see what's happening here. So first of all, by looking at the sliders, we found out that for this little guy, let me make sure you see what I'm talking about. For this little guy here, this was our vertex. And to move things down, the thing that we changed was we, remember this was our K value. So we moved it down 2, so that was our K value. And when we moved it to the left 1, that was our H values. But remember, it was x minus H. And so x minus a minus 1 is really a plus 1. So that was very key on that. And then the last component to look at was our slope. So our slope is always going up 2 and over 3. So we have rise over run. It is an upwards V, so it is a positive V, so it goes ahead and stays just like that. So now what we're going to do is look at the bottom one here and look at that same type of thing. So check it, check it. I'm going to use a different color just for the sheer joy of using another color. All right, so this is what we're going to look at first, this point right here, which is over at 3, 4. So remember, when you use your little graphers to move things up 4, it was the K that we moved. And to move things over 3, it was this guy, but remember, it was x minus h. So we went at, whoops, sorry about that. X minus h, so we want x minus a 3. Because remember, this is my positive value, but it always is x minus h. So we have minus 3. And then my slope is going down, and it is the rise over the run of 2 over 1, but it is a negative slope. So that is if you have the graph and you're trying to get the equation. What we're going to look at right here is what if we have the equation, we want to get the graph. So this is what moves it up and down. This is what moves it right and left. And this guy here is my slope. So this is up and down, right and left, and this is slope. So my vertex is equal to -4, -2. Remember, it is x minus h, so it's always the opposite of what's with the x. So we're going to go -4, -2. Bam, that is my vertex. Not a very good spot. There you go. And then my slope is -3, 2. So down 2 over 3, down 3 over 2, my bad, down 3 over 2. So that is a sad looking guy there. But that is my absolute value graph. All right, thanks for playing.